So pages 15 and 16 we did not assign as a homework set in your book. However, there are some good practice problems, so let's do a couple of them. Let's start with number 4. So sine squared theta equals sine theta. Rule of thumb is do not cancel out trig functions unless you're adding and subtracting them. So let's move everything to one side. I can factor out a GCF of a sine. I'm left with a sine theta minus 1. And then you take each piece and you set equal to 0. So sine theta equals 0. Sine theta minus 1 equals 0. For this one, theta equals, sine equals 0 at, on the top of the page it says for all the problems, 0 to 2 pi. So sine equals 0 at 0 and at pi, comma, for this one, sine theta is going to equal 1, and that happens at pi over 2. So these would be your answers. Let's try a cosine problem. Let's try number 6. Cosine squared theta minus 4 cosine theta equals 5. Before you pull out the GCF, you want them to equal 0. When you factor things, you want them to equal 0. So let's do cosine squared theta minus 4 cosine theta minus 5 equals 0. And then this is like algebra 1 factoring, but we first learned how to factor. Cosine theta, 2 factors of negative 5 that add and make a negative 4. If I do negative 5, its only factors are 5 and 1. So if I do a negative 5 times a 1, I get my negative 5. And if I add these two, I get my negative 4. So I'm going to put minus 5 and plus 1. Set each equal to 0. So you get cosine theta minus 5 equals 0. Cosine theta plus 1 equals 0. Cosine theta equals 5. Cosine theta equals negative 1. Cosine theta never equals 5. If you think about its wave, it goes up to 1 and down to negative 1. 1 to negative 1. So this does not have any answers. So over here, theta equals, cosine equals negative 1 at a pi. So that is my only answer. Let's try number 1. 2 cosine 2 theta plus root 3 equals 0. So we're going to call this an x for a second. 2 cosine x plus root 3 equals 0. And I'm going to subtract the root 3 over and divide by 2, so I get cosine of x equals negative root 3 over 2. Again, remember, directions say 0 to 2 pi. So x will equal, cosine equals negative root 3 over 2. Oops. In my second and third quadrants, and that happens at 5 pi over 6 and 7 pi over 6. Now remember, this says 2 theta. So I need to list twice as many answers, and to do that I'm going to add 2 pi, which is the same thing as adding 12 pi over 6. So if I do 5 pi over 6 plus 12 pi over 6, I get another answer. So let's write them down. X equals 5 pi over 6, comma 7 pi over 6, comma, now we add 5 pi over 6 plus 12 pi over 6 is 17 pi over 6, comma, then we're going to add 7 pi over 6 plus my 12 pi over 6 because I need to do twice as many answers, and you're going to get 19 pi over 6. Now remember, we didn't have an x, we had a 2 theta. So I need to divide by 2 and then divide all of these by a 2 or multiply them all by a half. So you're going to get theta equals 5 pi over 12, 7 pi over 12, 17 pi over 12, and 19 pi over 12. So those are all of your answers. Okay. 2 more. I found 2 more I think are good problems to do. Try number 11. So I'm going to pull everything over to one side. So I get secant squared theta minus 3 secant theta plus 2 equals 0. I'm going to move everything over to one side. We're going to factor this. Secant theta, minus 2 and minus 1. Factors of 2 are 2 and 1. Negative 2 times a negative 1 makes my 2. And when you add these together, you get your negative 3. So that works out. Take each piece, set it equal to 0. Secant theta minus 2 equals 0. Secant theta minus 1 equals 0. So secant theta equals 2. Secant theta equals 1. And I'm sure there's someone out there who's like, I don't know anything about secant. Okay, let's not call it secant. Let's call this 1 over cosine equals 2 over 1. I haven't changed anything. Secant is 1 over cosine. 1 over cosine theta equals 1 over 1. And then if you flip one side or flip one fraction, you have to flip the other side as well. So I get cosine theta equals 1/2. Cosine, this should be a 1 over 1. I get cosine theta, and then I flip it over and get 1. A reminder again, direction said 0 to 2 pi. So where does cosine equal 1/2? That happens at pi over 3 and 5 pi over 3. And cosine equals 1 at 0, but not 2 pi, because I have a parenthesis right here, not a bracket. So those are my answers. Okay, one last. Number 15. Let's do cosecant. So I have cosecant cubed x equals 4 cosecant x. Cosecant cubed x minus 4 cosecant x equals 0. They both have a cosecant, so cosecant x gets pulled out. I'm left with a cosecant squared x minus 4 equals 0. So you set a piece equal to 0. Cosecant, I need to write the right thing, sorry guys. Cosecant x equals 0. Cosecant squared x minus 4 equals 0. Cosecant squared x equals 4. Cosecant x equals root both sides and put the plus and minus root 4, which equals plus or minus 2. Okay. Cosecant x equals 0. That never happens, because if you think about cosecant's graph, it did this and this, but it never actually touched the x-axis. Never crosses that x-axis, so that never happens. Over here, similar trick, cosecant is 1 over sine. And then I can do plus or minus 2 over 1. So what that tells me is that sine x equals plus or minus 1/2. That happens at the over 6's. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. There's your answers. So hopefully this was helpful for you.